Switching gears from the function operations and composition, we will head back to those topics in a bit, but we need to define a bit of new vocabulary first. And the new big word is going to be inverse. Now we're starting off with inverse relations, so usually we use a letter like R to represent a relation. So an inverse is written with a little -1 up there where an exponent would usually be. That little -1 lets us know we're talking about inverses. If we were talking about inverse functions, which is what we'll be doing as we move forward, f is a function, f inverse would have that little -1 in the same spot. You may have seen that -1 in other classes, particularly in a physics class or a chemistry class. That -1 is just talking about inverse functions, so functions that undo one another. More on that later. To find an inverse, it's really not a whole lot of work. We need to switch our x and y values. An inverse is just a flip-flop of those two coordinates. Unfortunately, not every inverse is a function, which is why we're starting off by talking about relations. So a function is called one-to-one if its inverse is actually a function. It is possible to have inverses that are not functions, and so then that function couldn't be considered one-to-one. So there's a lot of new vocabulary here. When we actually start using these topics, they're not too intense. If we just take a look at a basic relation here, taking a look at example 1, I have some x coordinates. Let's highlight those red. And I have some y coordinates, which will highlight green. In order to check that inverse relation, I'm just flip-flopping those x and y values. So my new relation, my inverse relation, note they do give me this -1 here, so I'm trying to find that inverse, is just going to be switching those x and y coordinates. So I have 4 total points. So 4 total points, -2 used to be a y value, it is now an x value. 4 used to be a y value, it is now an x value. -1 used to be a y value, it's an x value, and -2 showing up again. Likewise, all of those x values now become y values. So flip-flopping the x's and the y's, really it's just that when we're talking about ordered pairs. So not that big a deal. Going back to functions, is R a function, the original relation, the one we started with? Well, keep in mind, a function means that that x coordinate, whatever your x coordinates are, one x coordinate has to map to exactly one y coordinate. So I see a 1, 2, a 3, and a 4. So each of those x coordinates shows up only once. Yes, that's what a function looks like. So 1 goes to -2, 2 goes to 4, 3 goes to -1, 4 goes to -2. If 4 also went to like 6 or 7, then we wouldn't get a function there. Going over to our inverse, we do have an issue. -2 shows up twice. So now that -2, which used to be a y coordinate, it is now an x coordinate when we do the switching of x and y. Because it shows up twice, this is no longer a function. R inverse is not a function. And since R inverse is not a function, R, the original relation, cannot be considered one-to-one. So this is just the vocab and playing with it, getting comfortable with these ideas. The reason this is important is when we start using inverse functions, we have to keep in mind what things are going to be allowed, what things are not. It's going to be really interesting, for example, when we involve square roots along with our quadratics. We've seen in the past taking the square root of x squared, for example. Something like this actually spits out the absolute value of x, not quite what we expect. Algebraically, we want for the square and the square root to cancel, but things don't always work perfectly. So that's where this is heading, talking about those kinds of relationships. Let's do a second example, one that works out a little nicer for us. Go back to the same methodology here, letting those x values be red and those y values be green. In order to get the inverse relation, again, we are just switching those values. So what used to be y values, 5, 6, -4, and 9, those are now x values. And what used to be x values, 1, 1, 3, and 4, those are now y values. So switching our x's and y's there. Note that we have a relation, r, the one we started with. Keep the same convention there, highlight that yellow. That started off not being a function because I had that 1 show up in the x-coordinate twice. However, our inverse is a function. So that's a little bit nicer from last time. Note, though, that a function is called one-to-one. R is not a function, so this is still not a one-to-one relationship, even though the inverse was. We need both R and R inverse to be a function in order for the thing to be one-to-one. Let's take a look at one more example. Now, instead of coordinates, what we've been given is one of these mapping diagrams. We haven't seen one of these since first semester, but keep in mind what this means. This arrow is telling us that 0 gets mapped to 6. In other words, the point 0, 6 is inside this relation. If we were graphing this, 0, 6 would be one of our coordinate points on the graph. So we haven't seen one of these in a while, but we can still play the same game with relations and finding inverses. So if 0, 6 is one of my original points, well, switching the x's and the y's there, that will give me 6, 0. So all we're doing still, switching those x's and y's. Let's go ahead and do that for the other couple of points. All right, so we had 6, 0. That takes care of the first one. We used to have the point 1, 2. So now that's going to become 2, 1. And last but not least, we used to have the point 11, 6. That is going to become 6, 11. So once again, we're in a situation where we started with a function. Our original relation here is a function, so that's quite nice. However, I wound up with an inverse, which was not. Because I have that 6 coordinate show up twice in the x position, our inverse here is not a function, so R is not one-to-one. So keep in mind what we would want is for both R and its inverse to be functions in order to be one-to-one. So we've got 3 examples here of different kind of things that can happen. Stay tuned. We'll show you another way to check whether something's one-to-one if you're given a graph, which winds up being even quicker than this method.